Okay.
Rewind.
Okay, so we'll do the graphing reduction theorem one first.
Okay.
So it's written as it's y equals a negative sine x plus square root of 3 cosine x. Okay, so the first thing we do is there's a formula we use. We have to find a. So we want to write it in this form. We want to write it in. Gosh, yeah, that's it. Y equals a sine. And then let's just put x plus b for that. Okay, so what we first do is to find a. I'll just write the formula first. It's a equals the square root of I'll just put this, so it's cosine, so really it's sine x and then cosine's value. So
Okay.
sine's right is -1 squared plus, just make sure, okay, yeah, plus root 3 squared. All right, so we end up getting 1 plus, okay, so 1 plus 3 really, right? Because that ends, so we get a equals square root of 4, which equals 2. So first, so now we go y equals 2. And then we put, so this is where the fun part is.
So where do we get the 1 and 2 from?
So right here, the value in front of the sine is the first value.
Gotcha.
And then the value in front of cosine is your second value.
Okay.
So then we got that. And now we have to do, okay, how did I get that?
Did you, sorry, is that 1 -1 squared?
Yeah,
Okay.
sorry.
You good? Just making sure.
Okay, cool. Okay, I just gotta figure out one step because I couldn't write it down very well. Oh, that's right. Okay, so here's the graph.
Sorry. Wouldn't this 3 be the square root of 3?
Because this is the, oh yeah, this is the square root of 3. It's something like this. Because that cancels that, but we still have it there.
Yeah.
Oh, but wouldn't it be, but that cancels that, and then we have 1 plus 3 under the square root, which would give us, so this would equal square root of 4.
Yeah. Okay.
And then we got that.
Gotcha. Cool.
Okay, so we got 2. So this is the part that I didn't get for a while, but here it is. So what we do is we take, so to graph it, this is how you find out what value. So right here we got sine, right? And we have x, but we don't know what this value, what b is. And this is what the graph gives us. So we got -1 sine, right? So let me just put this. So we got -1, so we go 1 over, right? So we go 1 over, and then we have to find the value of, what's it called? Square root of 3. 1.74. So we go over 1, and then we go up 1 point whatever, right? And we'll just put it right under the 2. Okay, so that's our point. And now we have to find, if we had our little wheel, which line would come into that point.
Probably the,
That's what I was thinking, is this guy. So it'd be, so then we take the value of, we just take the radian value, so it'd be 2 pi thirds.
okay.
And so,
I'm super
okay,
sorry.
there you go.
This point right here, where did it come from?
It came from this.
Gotcha.
So we get, that's your x, like right, your x, or whatever.
And one, that's
your
Y.
That's your y.
Gotcha. Okay.
Usually it's the opposite, right? Usually it's, usually you put your cosine on the x value, on the x-axis, right?
Uh-huh.
No, or is the cosine's y value, isn't it? No, it's x value. It's
I'm
x.
all confused.
It's x. Yeah, it's the x value. Usually, but
Yeah,
this one,
sine is Y, cosine is that.
yes. Isn't it? That's what I thought.
Yeah.
Because if you look at those stupid points, it's x, y, whatever. Doesn't matter. All that matters is the first thing is how many is the x-axis in this equation, and then this guy, the cosine, is how we move up.
Gotcha.
Okay, so we come over here and see 2 pi halves. So that's the equation that we have to use. Okay, and then it's probably going to ask us for each part. So okay, so all we have to do now, and then graph the function using the reduction theorem. Rewrite it and then graph it. So we did graph it. That's all we needed. So pretty much all we do is we just grab this and go, okay. But I'll just do this too. So usually he's going to ask us to find the period, the phase, shift, and amplitude. So amplitude is 2, phase shift is 2 pi thirds, and then the period we know that is 2 pi over v.
So it's just pi.
So it ends up, yeah, so 2 pi
No,
over
wait,
v.
sorry. This is equals mx plus b. So this is b. Okay,
Yeah,
my bad.
you just do 2 pi over 2 pi thirds, right?
So it would just be 3.
It would be, because let me see how I did that one. No, that's not it. It's not that. It's not that. Because this guy, I got 2 pi on this one. Oh, I'm thinking B is what's in front of it. X.
That's what I was thinking.
So it's in front of X. So it's just, it ends up being 2 pi.
Okay. Yeah, gotcha.
Because, like, it has to. Because I was like, that doesn't make any sense.
Okay.
Answer.
Sorry, what did you do this last equation again up here?
So how we got that guy is, so, yeah, so you got the right answer, which is nice. But we have to graph it, which is a little different. So we get the 2 from this equation.
Okay.
So the equation really is A equals, we'll just say, just for the heck of it, A squared plus B squared.
Okay.
Right? So whatever value is in front of cosine and whatever value in front of sine, we plug into this guy and get the A value. We keep it sine because sine is the first thing, and then we get this value from this. Okay. So if we graph, see here's the graph. Yeah, so we have this point right here. Okay, so that's we'll keep that point right there. So if we looked at cosine's graph, or sine's graph, right?
Mm-hmm.
sine's graph is this point is a starting point, right? 0, 0.
Yeah.
Okay. And then so the next point for pi halves is in sine, pi halves is 1. Sine's 1, right? So let's put that, there's 1 right there. And then the next point is, what's the next point on it? It's pi. Is it pi? Okay, pi and pi is 0. And then the next one is 2.
It's 3 pi halves.
3 pi halves. 3 pi halves, and that is -1. Okay, I'll just stick it right here. And the next one is 2 pi, right?
Yep.
Okay, so that's 2 pi, and he is 0.
Mhm.
Okay, then we just throw this stupid thing. Okay, so now we look at our equation, and it looks like the first point, because what we have 1, 2, 3, 4 point. No, 1, 2, 3, 4, 5. And there's 1, 2, 3, 4, 5. Okay, so this is what messed me up on my test too. This is why I missed some points on this stupid graph. Okay, so this point is that point.
Yeah.
So this would be pi halves, right? And this would be pi.
Yeah.
So this point goes to there. That's what I'm looking at, looks like. Which I don't quite get. So the phase shift is 2 pi thirds.
Yeah, so this is actually, it actually is going to 2 pi thirds. I
Okay,
believe.
so we'll just put that there. Okay, so this guy is pi halves. This guy is pi. And this is 3 pi thirds.
Wait, so the point is 2, yeah, so the point is 2 pi thirds.
2 pi thirds, which is just past 2 pi, right?
Yeah.
But not quite there.
Yeah.
So that'd be like right here.
Wait, no. It's just behind it.
Just behind
Yeah, just behind pi.
pi?
Yeah.
Okay.
Because 2 pi thirds.
2 pi thirds is, oh yeah, it's right here. It's right in the middle.
120 degrees.
Yeah. Okay, so we got, so now let's not screw up this time. Pi, okay. So it goes right here.
Yeah.
Somewhere right there. Okay. Or let me use red for it. Okay, so let's use red for our new graph. So we put it right there. Okay,
Yeah.
I'm not mixing markers, I'm sorry.
Okay.
Okay, so then this guy, which is at pi halves, this one goes to that new point.
Yeah, exactly.
So the new point would be that it'll be 2 right there. Okay, this point, which is pi, goes to this right here.
Yeah.
Because every unit's moving 1 to the left.
I think so. Yeah.
Is he on the inside of it? Yeah.
That is.
So he'd be moving from like here to here.
Yeah.
Okay. And then this guy moves. So he would move in between these two,
I think so.
right?
Yeah.
Yeah. So he moves in between these two, but still at negative. Okay, and then this guy
This one's right here.
moves right in between here. And we do our new one. Man, I wish we could take our tests with each other. We could kill it. Okay, that makes sense, right? Because if we would do it, the period is 2 pi. So that's the highest it'll go, right?
Yeah.
The phase shift was 2 pi thirds, but because it's a plus, it's really shifting left. So we got that, and then the amplitude, period 2 pi. That's just this.
This one goes down 2 pi as well.
Is it?
This is 2 pi.
This
Yeah.
goes down to 2 pi?
Yeah.
Let's just look at this guy. 2 pi.
Sorry, that's not just 2, not pi. I apologize.
No, because the amplitude makes
Yeah.
sense.
Sorry.
So he goes there. We got, oops. Okay, so that makes sense to me. because, oh, this actually just is 2 then. That would make sense. Okay, that makes sense. That makes a lot more sense. Because the amplitude is 2, so the highest it'll reach is 2, lowest it'll reach is 2.
Yeah.
Phase shift is 2 pi thirds, which is not a full unit left, but close. So you don't move quite a full unit, but you move a little bit. Then the period is just one of those, right, from 5 points.
Yeah.
So if it was 4 pi, we'd have to do 10 points. Am I right?
You would still do 5 points, but they would just be.
Go to 4 pi.
Yeah.
Okay, that makes sense to me. All right, we're good. That makes sense? We're good?
Yeah.
I think we got it. Jordan's still not with us. Okay.
I wonder where's that?
I don't know, man.
Texted him.
Did you text him? Maybe he forgot.
Your call has been forwarded to automated voice messaging system.
He's like, man, I'm sleeping. I don't want to talk to you. Okay, so that problem, we're good. I think we get it. Okay, so there's one problem on here I was looking at. I'm like, I don't quite know. But I know how to do this one.
Okay.
Okay, so I'm erasing this.
Cool.
Erasing all this good stuff.
Quality work right
So does that make sense how to find the b value of the new equation?
Kind of. I mean, I'll just have to do it on the.
I'll show you. I can show you a different problem.
Yeah, that'd be good.
Okay, so here's. I'll stand it up so we get a little easier. Okay, so here's the problem that I have on the homework for number 7. So on lesson 1. So I'll just write number 7. So the equation is y equals 3 sine minus 3 root 3 cosine. They both are x, not alpha. Okay, so that's what it is. So we do this problem, remember a is a stupid equation, and we get 3 squared, and we get plus, plus 3.
So the normal equation's got a minus in between the
Yeah.
things, but it cancels. Gotcha.
Yeah, because it's I have a plus and a plus. So I have 2 pluses. I have the equation equals a equals square root of a squared plus b squared.
Okay.
So that's, yeah, this equation has a minus, but this equation has a plus.
Gotcha.
So we just switch the sign. So, yep. Good. I know I got this problem right, so we're good.
Okay.
I did this. No. How did I do this? Oh, that's why. I think so. Because this kills, like this guy cancels, right? And then we have, is that 3 times 3?
Yeah,
Which will give us 9.
but you're squaring the 3 as well. So it would be 9 times 3, which would be 27. I did my calculator just now, so.
Okay, so this would give us square root of 27.
No. So, sorry. Oh, so this would give us, it would be
9.
square root of 9
Yep.
plus 3 squared is 9. And
Okay.
then the square root
Times
of 3
3.
times it. So it'll be
So-
9 times 3. So
So
it'll
it's
be 9
27,
plus
right?
27.
Okay, that's what I thought. I remember I did it, like I was like, it didn't make sense, but we end up getting square root of 36, which equals 6.
Cool.
Okay, so
That's
y,
nice.
yeah, it's really nice. Y equals sine 6 sine x plus. So this is what we got up here for the graph to find the b value. So we got 3 sine, right? So 1, 2, 3. Okay, so we go over 3, and then we go down So do 3 times square root of 3.
5.19.
Exactly. Okay, so we got, that's what I thought. We go right here, and it's like right there. Okay. So if we, on our unit circle, what's the first angle? It's 5 pi 3.
Okay.
So this is how I kind of did it. Like, because there's a couple other ones that are different. Like, you could hit similar question later and do a different one. And another one I had like an angle here. Another one I had an angle here. Right. So we just draw those. So like this would be 5 pi thirds. And then this, like the next one would be 7 pi fourths. And then the next one, of course, would be 11 pi sixths. So really it just depends on where the point is.
Mm-hmm.
And you match it up with where the corresponding angle.
Yeah.
So I guess that make a little bit more sense. And it's not like, I kind of like struggle. This is the only part on this problem I struggle with. Because I was like, how the freak did they get this? Because I looked at like an example. I'm like, how'd you get that value? And then I was like, okay.
Yeah.
Plot it. So, okay, so we get 5 pi thirds. So then we go period. And phase shift. So phase shift is 5 pi thirds. The amplitude is 6. And the period is 2 pi. So that's it. If we graph this one, I don't know. This graph would look a little different.
Mm-hmm.
Because we're shifting 5 pi thirds, which I don't even know. Like that has to go through a heck of a lot of
Shift.
which is not, it's not too bad, I guess. Like 5 pi thirds, because we go, here's pi halves. I'll scoot this out a little bit. Here's pi. Here's 3 pi square halves, right? And then here's 2 pi. So because it's plus, we know we're shifting it this way. And 5 pi thirds is just right here, isn't it? Huh?
Sorry, George texted me. He said, hey, sorry, I had a meeting.
What meeting? What meeting's more important than this?
Exactly. I mean, this is trigonometry we're talking about.
Right, so this will be 5 pi thirds right there. Right after 3 pi halves, right? Yeah.
Yeah.
Yep. So it'd be here, right? So we're shifting everything. So if we graph the sine one again, right? Here, 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 and we're shifting everything 5. We're shifting it. So do we end up shifting it 1, 2, 3 units like that? Left?
I think so.
Okay, so this guy, we go as, let's scoot it out a little bit. 5, 3, 5, and 2, 5. So he would go 1, 2, 1, 2, 3. He'll go here. But then we have an amplitude of 6. So we go 1, 2, 3, 6. So he stays there. This guy is gonna go 1, 2, 3, 4, 5, 6. He is coming up. So he goes, what is that, to here. So 1, 2, 3 here. 6.
Okay.
He stays there. 1, so 1, 2, 3, right there. This guy goes 1, right, 1, 2. He's on it, right? 2, 3. So he'll be right like there.
Okay.
And then this guy goes 1, 2, 3, he'll be right here. Right?
Okay.
So we do this. This is the ugliest graph ever. Where is it? Right there. No, there. No, there. Okay. All right, that would be the graph. If I would have drawn it to scale, this one would be a lot skinnier too.
No, that makes sense now.
Okay.
Cool.
Yeah, these ones, these are like, I just hate graphing problems in trig.
Yeah, guys.
Algebra, I get it. Trig, no, not so much. Okay, cool. Okay, so the next problem, which is like the solve sine 2x equals sine x for all solutions. I'm not positive. Sorry, I can turn this towards you.
Very good.
I'm not positive on how to do it, but looking at it, because all real numbers are all solutions, right?
Yeah.
Okay, so, okay, we do know how to do it. Okay, this sucks.
Boy, calc looks awful.
What? Yeah. Okay, let's see if we can look at that and get the answer. Okay, so here, I'm just looking at my stuff and we'll see what I can do.
Okay.
Okay, so he gives us sine 2x, sine 2x equals sine x, right?
Yeah.
Okay. I think what we do is we plug in this problem. I think we plug it in for this, right? Would be, it goes sine, 2 sine x cosine x. I'm pretty sure. Because, okay, so he got 3 solutions. He got pi thirds, and 5 pi thirds. So just looking at that, I can kind of see. So we got pi, sine of 0, pi thirds, cosine is.
What is this k that's in here?
Where? The k? Oh, so you'll learn about it. Oh, it's like a place kind of holder. Like all you do is you just have to know the value that goes by it.
Okay.
And so this guy, see, like k is by itself, k is by itself, k, like, right? So we have 2 pi, and pi. This is
Okay.
this is where I'm just like, I hate this. Because I hate it because if he gives me a problem similar to how it is, I can do it. But when he gives me a problem, like, freak, I don't know how to do that. Because like this is one on the homework. It's super nice, right? Okay, you got sine x equals -1.
Okay.
Okay. So you look at it, you're like, that's like, how the heck do you do that? Like I looked at it, I'm like, I don't get it. So here we go. So the solution set goes to this. Whew. Okay. So we know this is why this problem's nice.
Mm-hmm.
When is sine -1?
When it's going down. When it's going down, yeah.
Right? So this value,
Yeah.
that's the only time it's at.
Okay.
So that's your value, right? But, and this is what screwed me up forever. Because you can't, like if this was pi, then this wouldn't exist, right? Because it has to be greater than pi to get that.
Okay.
See, because like 3 pi, right?
Yeah.
So anything that is less than pi goes here.
Okay.
Anything, I mean, sorry. Yeah, less. less than pi. Right? A is less than pi. And then anytime that A is greater than pi,
Yeah.
2 pi goes there.
Yeah. Okay.
So that's the way you can do that one.
So then here we'll always go either pi or 2 pi every time.
Pretty much. I haven't seen anything else. Unless like K. So when you get into further equations, the pi's can cancel and you can have K over it. But I'll show you for example.
Okay.
But yeah, so that's like, so that would be that answer.
Have you done all of my math live this week?
Yeah.
So jealous of you.
Done. It took me, the first one it wasn't terrible. Like lesson 1 just has some sucky problems, to be honest with you. Lesson 2 isn't bad. Like I got lesson 2 done pretty quick. But it's a little bit more like, I don't know, you gotta kind of try to hard to understand it. It's just weird. So like this. So like I got that one. That one's easy, right? So you look at this problem, I'm like, that's why I'm like freak.
Uh-huh.
If I remember correctly, because I think the problem I have close to it, I just don't have any problems like it. Oh, yes, I do. I have that one that's like it. But that, I don't like that problem. Because that one actually had values. Well, it's not a value, I guess. So this is how we did this problem. See, that's still not the same. Oh, yeah, I can. I think you do this. I think you minus sign x minus sign, right? And it equals like 0 or whatever. Or what do you equal 1?
No, it equals 0.
0, right? Okay. So I think that's how we do it. But I'm looking at this one. And they have a problem like this. So it's 7 sine squared x equals sine x. And it tells me to do this, to substitute sine for y for sine. So you 7y squared equals y minus y minus y. You get 7y squared minus y equals 0. Correct? Yep. Okay. So that's what I'm thinking we do up here.
Yeah.
And we factor out the sign.
Gotcha.
So we got this, right?
So where did this cosine come from?
You have to use the identity of that guy, which is right. The identity of doubling identity goes to 2 sine cosine.
Okay, cool.
I'm pretty sure. Okay, so we do that. Okay, so here we go. This one just always makes sense, and I can just do it. It was y 7y minus 1 equals 0. If I'm correct, which, yeah. Okay, and then we just set them equal to 0. Y equals 0, and 7y minus 1 equals 0. Okay, like this one I'm saying is someone takes forever because you got like a billion problems. And so then we just solve for y, right? Plus 1, 7y equals 1 divided by 7, y equals 7. This one over here is equal, easy, it's 0.
The 1 over 7 over here?
Yeah, that's fine. Okay, and then so this guy, so here's how you get the values. This is what freaked me out forever. So y equals 0 has 2 values. 0 and, is it 3.1? Yeah. And 3.1.
Where did that come from?
I'll show you. And then this one, y equals 1/7 has 2 values. It has 0.1 and 3.0. Yeah, right? You look at that, like how in the crap does that work? This one's easy. 1 divided by 7, you round it to 0.1.
Gotcha.
This one's easy. 0 divided by anything is 0.
Uh-huh.
Okay, so here's how you get this values. Okay, so you have, and this is why I kept messing up forever. You have to switch your calculator to radian.
Okay.
Right? And then you plug in these values, and you get
this.
You get this, like screw, like
Yeah,
just
I can start on this one.
Yes. So what you end up doing is you go sine inverse 1 divided by 7, and that gives you like that number, right? Okay. Same thing with that. So this guy, I remember I got this one because it's it was you do it all in, you end up equaling 1. Sine is like sine's 1 or whatever.
Okay.
And you get, when sine is 1, you get, man, how did I get that stupid? I know it's right because I got the problem right, but I think it's, oh, that's right. Okay, because 0 to 2 pi. Okay, how in the heck did I get 3? I don't know if I plugged it in if I got 3.1. 7. Yeah, see, that's not it. Okay, let's look up in my math lab real quick. Because I'm like sitting here looking at it, like, yeah, I'm not getting the answer. And then we'll do the top problem. I think that we know how to do it. I'm just overthinking it.
Yeah, it's usually the case. I mean, you know how to do it.
No, man, this stuff, like, that's why I'm like freaking out about our test. Because I don't know if our final has everything on it or just has the last like 2 or 3 chapters we've done.
I kind of hope it just says the last 2 or 3 chapters.
I'm doing 2 because I think it has, hopefully it has the last 2 because the last 2 chapters are hard.
Yeah.
Like proofs and identities and unwritten rules you can use with these identities. You're like, how the heck did you do that? How did you do that?
Which my math lab
So
is
it's
it?
the very last one.
Last one, last problem?
No, it's problem 7.
7, okay.
But you probably have a little different problem than I do. Maybe you don't. That'd be nice. Yeah, I see you go. Okay, and then I will look at how to do it. No, you got the same. You got a very similar problem.
Okay.
Not 7. What am I talking about? It's 10. Sorry.
Gotcha.
I can't read very well.
You did.
Yeah, look at you. I was going to say. So you got 9. See, that's similar to what I have.
Yeah.
Okay, and so here we go. Let's see. I'll just do help me solve this because I've already done it. Okay, so we do this. They get the first step right. They get to pretty much what we got.
Okay.
Okay, so we got 7 watt minus, okay, got that. You factor it, you get y. Y 7y minus 1. Okay. Now we get to that. We got that. So sine x equals 0 and substitute it into both equations.
Okay.
Okay.
Got that. Got it so
Got
far.
that, yep. So solve the first equation, you get 0. And then this is where I wish it would show us. Duh. Where does sine equal 0?
There and there.
Okay, so it has to be between, this is how you know, because the answer has to be between, where's 10? Between 0 and 2 pi.
Okay.
So you can't like, 0 is included, but pi is 2, so 2 pi is not included.
Okay.
So it can't be 2 pi.
Yeah. Gotcha.
So it has to be pi.
Okay.
Which is 3.1 if you round it. That's makes sense now.
Okay.
Because you just look at that, sine equals 0. This one's a little more difficult.
Okay.
Where sine equals 1/7, you get, right, 0.01 because 1 divided by 7 is not that. But sine of 1 divided by 7, inverse sine
1.433.
is 1.4, which it says round to the nearest 10th.
Gotcha.
Or 0.1. Okay. So now here is the one that I have to remember how we got it. Because it's 3.0. And I remember getting it. It took me forever to get it on my calculator.
3.0 is the
Is the answer. Is the other answer. It's 3.0. Because that gives us 1.4. Look on yours and maybe it'll show us. So let's see if that works. 7 sine. How do you square the sine? Do you have to do it outside of the parentheses?
So
Okay. Yeah, see, that gives us the same big thing. 7 sine 1 divided by 7 equals. And then you square it, and that still doesn't give you a. Because I remember. I don't know. I know it's the answer, but I'm just like, why? I can't remember.
yeah, I don't really get it.
I don't remember how I put the numbers in. It got 3.0. Oh, okay. Yes, I do. Yes, I do. Here you go. Because so this angle 1/7 is going to be smaller, like than pi.
Okay.
So you take pi minus the inverse sine of 1 divided by 7. No, that's not it. But that is essentially what you're doing. You're just going to do this. You're going to take pi minus, that gives us more. I'm pretty sure that's what it is. So 1 divided by 7, yes. Okay, so 1 divided by 7 equals right that. So you go pi minus 1 divided by 7, and it gives you 3.0. Now
So
I get it.
why do you take pi minus that?
Because that angle is smaller than pi.
1/7. Okay.
Yep. Because pretty much, like if we go by this, sine equals 0, right, is going to be 0 and 3.1, which is right, it's going to be in here.
Okay.
So then we go over here, and 0.1 is within here.
Okay.
So then we know that we have to minus 5. So if it was over in here, so if it was greater than, which there's some that will be, like I'll have an example right here. This is pi plus or whatever.
So I don't 100% understand. I'll just kind of go over it a little bit.
Yeah, go for it.
And we can do it. So first 0.
Yep.
And then the second point, we're taking the, well, we know that sine is 0.
So
is
we
pi.
exactly. So you take 5. The decimal form was 300.
Okay.
So then you take that value. Perfect.
And then we know that,
Take pi and minus that value from you.
so we take pi and subtract
1/7, and you get 3.0. Rounded. Okay.
And this was
So like this problem, there's a problem. Yeah. So like number 11 on your homework, you'll see it's crazy. So like number 11 on your homework, you do exactly what we did. You take because the inverse pi sine is the same as just dividing the two, right?
Yeah.
So you take it. I'm gonna have to do that one. This one's a little better. I think it's a little easier to explain and see how it does. Yeah, but so that's how you do the stupid thing. And this one right here, I'll show you. You actually use 2 pi and, because though I'm gonna leave this problem up, because then we have to solve it. And I just don't, I'm not quite sure. Oh, I think it might be this. Duh, okay? This, when is sine 0?
At both sides.
Okay, so pi,
yeah,
right? When is cosine 0?
At pi halves and 3 pi halves.
Okay, right, so we're gonna put the pi and we'll do pi halves, okay?
Okay.
And then we'll do, then sine, when is it? Okay, let's look at his answer sheet. And I think, if I think, yeah, pi 5/3 is that one. So the other one is 2 pi, right?
Okay.
I don't know, maybe not that one. I know these two for sure.
Okay.
What's pi 5/3? It has to be 2 pi.
5 pi thirds is.
Yeah, it's right here.
Here.
Yeah, so that's why it's not making any sense to me. Because,
No, wait, sorry, you're right. It's okay. I'm talking crazy. Yeah. So
yeah, whatever.
it's this one. It's this one.
Okay.
This
one, yeah. And so this one, I think it's 2 pi, but whatever. Let's not focus on home right now.
Okay.
So we have to do this thing because this 2 is in front of it. Then you'll see it makes a little bit more sense.
Okay.
I think I'm starting to get a little bit better, but I'm not great at it. I just what I've learned from homework. So this problem over here, 9 sine squared minus 3 sine x equals cosine x. Right? No, cosine squared x. Okay. So this is where we have to use our stupid identities. Cosine squared x, right? If we're using the Pythagorean identity, ends up equaling 1 minus sine squared x, right? So we just get this, and then we're going to take that whole thing and move it to that side. Correct. Yep. So right, we got 9 sine squared minus 3 sine x equals that plus that on each side. And then we're also going to minus that on each side. We get 9 sine squared x minus 3.
Sorry, how do you do this step right here?
Just the Pythagorean identity.
Okay.
Because the Pythagorean identity, right, is sine squared x plus cosine squared x equals 1.
What is?
So this is the equation that you get.
How do we get that?
He gives you this.
Oh, okay. I am on the same page now.
Okay.
This is what I was confused about. I was like, where did this come from?
Yeah. So this is like this problem. It's kind of like we're doing a proof, but only we're solving for exact values.
Gotcha. Okay.
Okay. So you got that minus sine squared x minus 1 equals 0. Right? No, plus. Duh, plus. I plus that. Okay, plus that. Okay. So here's where the fun part starts.
Like, so this guy.
This is my problem.
Oh,
I'm gonna
okay.
show you
Oh,
how we have to
I
use
thought
the
that we
two
were
signs.
getting this from that.
No. This problem is completely different.
I
Sorry.
was so
You're like, dude,
confused.
what the freak are you doing? You're screwing this whole problem.
Well, I was like,
Like I'll tell you, like it threw me for a windmill trying to learn all this crap. So here we go. We just plus the things together. We got 10 sine squared x minus 3 sine x minus 1 equals 0. Okay. And now what we're going to do is we're just going to go to values of this, like products of this that equal that. And so we get 5 plus. No, it's 5 sine. Yeah. Okay, so we got 5 sine x plus 1. And then we got 3 sine x minus 1. right? Right? No, 2. That's what I meant to do.
Gotcha.
2 sine. That's right. 5. 5 minus 2 is 3.
Yeah.
And then if you times that all out, you get that equation.
Yeah.
Okay, so here we go. Now we do sine. This guy is gonna sine x equals 1/5, and sine x equals 1/2. Okay. Here's the fun part now. We'll start with 1/5. Start with him, and he's gonna have 2 values, right? And he's
Yeah.
gonna have 2 values. So we go sine, right, of a negative 1/5.
Is it a negative 1/5?
Yeah, because you would get like this, right, equals 0, minus 1 divided by 5.
Okay, so this should be negative 1/5. Okay.
Yes.
Gotcha. Cool.
Yeah, I just forgot to put minus. Yeah, so here, right, he equals like negative 0.2. 1/4. So we go pi minus 0.214 equals, okay, equals 3.3 when you round it. Okay, so that's the first value. So now we do 2 pi plus a negative.
For this same situation right here.
Yep, same. So this is just for this value. Okay, plus a 0.014, and it equals 6.1.
Okay.
Okay, so now we have to do this value. So we do it sine of 1/2 equals, which is nice, equals to that. It's kind of like the other one we did. Okay, so now we just plug this guy in. But this is our first solution this time.
So why was that one not my first solution?
If I remember like correctly, because it was like it has to do with it being squared. To do with us putting, because this is squared, this guy isn't. If you read the what's it called, the few example, it kind of makes it really. It just gives us 2 sentences to read, but it talks about being squared. So that's why this guy's not. But the second one, because he is not squared.
Okay.
So that's the first one, and then the next one is just pi minus. We have to go back because this is rounded. If you don't have to,
okay,
and you get 2.6 as your, so that would be your third. This would be your fourth.
Okay.
So that's what this one is not quite like that, because you'll learn there's going to be like stupid solutions, like you can say from this one to this one. So, but yeah, that's how you do that problem.
Okay.
A little overwhelming.
Yeah.
Just because you don't like.
Yeah.
It's just tricks, and like there's some things you just say, this is what you do.
Yeah.
It's like, I hate that.
Yeah. No, it's definitely.
Okay. Weird. Now we'll solve this stupid problem over here. And then we'll shoot. Well, then what we'll do, we'll solve this problem. Then the other ones, don't worry about it. Like these ones, there's a problem just like that in your homework. You can give you example. You can do it. But then we'll do this problem, and then we'll shoot for this one that we can do.
Okay. Cool.
And he actually does step for step, so I think I'll be able to actually understand it. Okay, so here we go for this one. So he's saying the solution set. I'm just gonna write a solution set up here. Maybe me and you can figure it out. How much time do you got left?
I'm not impressed.
You sure?
Yeah.
If we do, then you're all good. Okay, so this is the first solution. Okay, that's the first one. Second one, I know it's a 3, I'm sorry.
Okay.
Second one is x. So that guy in x equals pi thirds plus 2. Okay. And then the last one is Right? Yeah. Okay. So I'm guessing, so what I am pretty sure you do yeah, so like, cause this is how, cause pretty much what we're saying now is sine, right, cosine. So what we're saying is when sine is sine x equals 0, right, we got pi and 2 pi.
Okay.
Right?
Uh-huh.
Okay. So that's like our first solution right there.
Yeah.
That kind of makes sense, right?
Okay.
And we got pi because it's not bigger than 2 pi. Okay. And this is the same thing. Like this one is like, this is where it starts to freak me out. Because there's 2 of them, right?
Uh-huh.
So it's really saying like 2 cosine x equals pi halves, right? And so when we do this, no, it's not saying that. Saying we have pi halves times pi halves pretty much.
Okay.
So it's really saying, because we have 2 cosines, right? And when cosine is 0, we have pi halves, but so you have to like times by 2, I think. Cosine, yeah, 2 times this, which this isn't working out how I wanted it to. Because we have to get it to equal that. Oops. It's got to equal this. And there's a way, freak. You minus them. Oh, yeah. Okay, because, sorry.
Very good.
So this one makes tons of sense to me.
Perfect.
Or does it? No, it doesn't. Yes, it does. Okay, I got it now.
Okay.
I think, but I'm not sure. So cosine, when does cosine equal 0? Is
2 pi and pi.
pi halves, right? Cosine?
Yeah.
Yeah, and then
Wait,
3 pi halves.
Cosine? Yeah, so you're absolutely right. My
Yeah,
bad.
right. And then the other one is at 3 pi halves.
Yeah. Uh-huh.
Okay, so if I remember correctly, because it has to do with the 2, that's what it's divided. Yeah, see, this is times. So if we it doesn't make any, that doesn't make it pi thirds. Because if we took pi halves times pi times 2, you would get 2 pi over 4, which still gives you pi halves.
Well, it would be just pi. Because
Yeah, see, then that's not right. See, okay, so this is what it has to do with, not this guy, whatever. It has to equal, so like this, right, has to equal this.
Okay.
And there's a way, like, so like this one will make a little bit more sense to you.
Okay.
Just to show you. So like you get cosine x over 2 equals square root of 3 over 2, right? So we look at the values. Say cosine at pi 6 is 3 over 2,
Mhm.
and we say cosine at 11 pi 6 is root 3 over 2. Okay, but it's over 2, so we have to divide the denominator by 2,
Uh-huh.
and you get the so like it would be, so you divide it by 2, right? So if 11 pi 6 was divided by 2, then 6 divided by 2 is 11 pi thirds, and that's like our answer.
Okay.
Okay, and so like pi 6, right, divided by 2 is pi third. But this is the opposite. This is saying 2 times something gives us that. So that's why I'm looking at this and I'm saying 2 times what, if we divided it out, would give us because it'll simplify to that. Right, so what did 2 pi 6, 6 equal?
Yes.
Yeah, I just don't get how it's pi thirds. What is pi thirds? Pi thirds equals root 3. It equals 1/2. Okay, I got it. I'm an idiot. By 2 cosine equals 1/2.
Okay.
Right? What is cosine? What is 1/2? When cosine is 1/2, it's pi thirds.
Gotcha.
Does that make more sense? Because I think if we did this and we like took this out,
That makes sense.
because I'm looking at this stupid problem here. We got 2 sine cosine minus sine equals 0.
Okay.
So forget this. Right, so if we do it in terms of sine, so like let's factor it, I guess. If we factored it, it would still be, it would take sine out here, right? Sine, or is it a negative sign? No, just sine. Okay, so this would give us in here, it would give us 2 cosine, right? Cosine x minus 1.
Yeah.
Equals 0.
Okay.
So if we set sine x equals 0 and 2 cosine x minus 1 equals 0, we solve for it. So that's 1 plus 1. 2 cosine x equals 1. Do it and got it.
Yeah, that
Okay,
makes a lot of
make
sense.
sense? Okay, so now this is where it's a little different because it's at 2 pi.
Okay.
And we have 5 pi thirds. So we got this guy. That one's easy, right? Sine
Got
x.
this one.
Yeah, we got this one. That one was easy when we figured it out. Okay, so now 5 pi thirds, which is 1/2, right? Cosine is 1/2
Okay.
because we have 2 cosines.
Okay.
Because also, okay, that's not true. It has to fit. So what did he ask? For all solutions, right? Because we're sitting here looking at, because if it was negative 1/2, right? If it was negative 1/2, you would come over here and we would look and see cosine of negative 1/2 at 4 pi thirds. It's also negative 1/2 at 2 pi thirds. And then we would have to see if those fit the equation, right?
Okay.
But because the solution is from 0, is all solutions, not like a set of values. Because like he'll give you one to, he'll say between 0 and 2 pi, like, and then you have to find the values, like all the numbers or whatever. But for this one, it just says find all solutions. All solutions. So this guy would actually work because it's still 1/2.
Okay.
Make sense? Okay, so we got this guy, sine equals 0. And we don't put in sine equals 0 for 2 pi because 2 pi, because you don't ever, it's not included. But yeah, so that's it. Okay, that makes more sense.
That's actually pretty easy.
Okay, once we get it down, you just solve them like that. Okay, so let's do the last problem, then we'll get back out of here.
Okay, sounds good.
Hopefully I'm not confusing the crap out of you.
No, actually, at the very end, it was literally complete confusion until the very end.
Yeah.
That makes sense.
So I had to like, as soon as I worked through to my brain, I'm like, oh, there it is.
Good.
Okay. So the last problem is, and we'll pretty much just both go through it. And the last problem is, okay, there it is. So find the solution. So 6 sine, I'll let you do it.
Cool. 6 sine x squared, or 6 sine squared x minus 2 cosine x.
Cosine x equals 5. Okay. And we're looking for a solution between 0 and 2 pi. Okay. All right. And I'm just going to sit here and look, because I'll look at the problem step for step and see if I would have done it this way.
Okay. So do I subtract 5 over first?
No.
Oh, might have turned off wrong.
So I would factor what sine squared is, because this,
Okay.
so this is the thing. This is another rule I totally forgot. On that last problem, right, we had sine cosine equals sine.
Uh-huh.
So pretty much we're looking at this problem because this doesn't fit like right with this.
Uh-huh.
So we're gonna try to solve for this.
Okay.
And so when this is that stupid identity thing again.
Yeah.
What equals sine squared? If
1
you-
minus cosine squared.
Boom. So you just put the subtract, you substitute that in for it. Okay, perfect. Now I think you got it. I think you can do it step by step now. Okay, so what's the first thing you would do?
Well, I can distribute the
Yep.
6.
Yep. Okay.
Okay. And then I can factor out a cosine. Do I really want to do that?
No, you don't.
I don't want to factor out the cosine.
This is where you want to get it to equal 0.
Okay. So then it'll be 1.
You can rewrite it how you want to write it. Too.
So I want it to be cosine.
This is the stupid thing.
So
This is why I forgot to. I always do this. Is this guy will turn to a positive
Why is that?
because he says so. But yeah, so I don't know why. Like, because you minus the 5, right?
Yeah.
And then you add 5, 6 minus 5 is 1,
Yeah.
right? And like those two are plus each other.
But this doesn't make any sense.
I know, but that's what he does. Oh, is there an identity?
I think I see what he does.
Is there an identity? Identity. Nice save.
Okay. So this is what he, I see what he does. He just basically puts
Flips
it on the
it,
other
right?
side, yeah.
Yep.
So this
He just
is
flips the problem.
square x plus 2 cosine x minus 1. Then we factor.
He doesn't. Okay? This is where it doesn't get, this is where I lost right here. Okay? I would have done exactly what you did.
Okay.
And so he goes, I'm trying to find the identity for it though. Look what he does. He looked at V in.
So he just basically replaces cosine with a variable, basically.
Mm-hmm. But I'm still not getting why he's doing that. Because he's using what's it called to get it.
I don't, yeah, I know what you're saying.
He's not even using trig, he's using algebra now.
We could do it our way, but I just think that it would turn out really ugly. So I think that's why he's doing it that way.
Because he is pretty much, what's that stupid thing called again? It's when you're trying to find the,
I forgot the name of it, but
right, it's the A plus, it's this stupid
What's
thing.
the-
B, right? I mean
Yes.
B. It's B plus or minus square root of B squared minus 2, is it 2AC?
I think it's 4AC.
4AC.
Oh, over 2a.
over 2a. Right, okay, that would make sense now. He plugs it in, but I hate doing that. It just comes out of nowhere, so I'm like, okay, so let's throw it in that equation.
Dude, my calculator will do that for us.
Yeah, I was like, I don't want to sit here and have to. Okay, and then we have to do our fun thing.
So we have 6. 2. Yeah. Okay, so for x, for one of our x's,
Okay,
we have x equals 0.27.
4, 3. Okay, so here we go. We got
X equals negative 0.608 rounded.
Okay, that's exactly what he got, okay? Now what we gotta do, here's the fun part. We have to do cosine the arc sine of 2.74
The arc sine?
of both of them. I mean arc cosine. That's what I meant.
Gotcha.
Yep, and get those values.
Down one digit just to go accurate.
Okay. So now we'll get the first one. Is it equal to something?
1.29.
Okay, so then minus that from pi. Pi minus that. Or pi, yeah, pi minus the other guy.
This is, sorry, this is
So take 1.29 out of like, so pi minus 1.29.
right.
And that's our first answer. I can do it. No, I'm sorry. What's the, yes, okay, that is our second answer. 1.29 is our first answer. I'm sorry.
So you get 1.29.
Yeah. Okay, so that's the first one. That would be for,
This.
yeah. Which would be which one up there?
Which would be,
That doesn't matter.
okay,
There's two.
I'm guessing this one, I don't know.
I know. Okay, so then the next one, we should have two answers for that too.
0.60762, which equals, did he get 9.9177?
Yep. Okay, so that's
And then-
essentially the first, and then we minus pi. I mean pi minus that. So that's our first answer.
And this is,
So he got 2.2238, right? Is that what you got?
Yeah.
Perfect. We got the answers. That's it.
ow!
So all of those are answers. Does that make any sense to you?
A little bit confusing, but I mean, getting to this point, it makes sense.
Yeah.
Because we could have done it our way too.
It just
This
would have
is
sucked.
Yeah, easier.
Yeah, so I guess if we did it our way, which we would have done 6 cosine, right? We would have factored out a cosine, just so I can go through my brain. So if it was 6 cosine squared x plus 2 cosine x minus 1 equals 0, we would have factored out a cosine on each side. We could have actually factored out, what, 2 cosine?
Yeah.
Or you would just leave it? Just leave it?
Can we use, I mean, it's just foiling.
So this guy's 6 cosine x plus cosine x, right?
Uh-huh.
Minus 1. Okay. Because then we would have had to break it down and said, what does this equal? So this is pretty much saying cosine equals 0 on that side. But see, this is the crappy part. See, that's why I think you did it, because
Yeah, that's
you have to factor this into this. Like you'd have to do 5 cosine plus 1,
Mhm.
and then cosine minus 1.
that wouldn't work though, because cosine. times
Yeah, see,
cosine-
that's my point, because this would be, oh yeah, it's 3 and 2. Wouldn't that work?
Yeah, that'd work.
Yeah. So that's what it would be. And then we would do cosine equals 1 over 3, right?
Uh-huh,
And then cosine equals negative 1/2.
uh-huh. But then we'd also have this one too.
Yeah.
Honestly, I think that his would be easier.
No, that's what I'm saying.
Fine.
Like if I just looked at, like looking at our problem, like, fetch, then we have to find this one, this one, this one. That one just gives you 2 answers.
Is it okay if I erase it?
Yeah, you could. It'll give us a positive and a negative.
Cool. Well, thank you so much, man.
Hopefully it makes some sense.
Yeah. There'll definitely be a lot
Okay.
of video homework.
So, yeah, homework, you should be able to breeze through it. And then I have to study a lot for our test next week. I saw on iLearn that our test, our multiple choice test, was due Wednesday.
Okay.
Like this Wednesday.
Oh, really?
Yeah, I was like, what the freak? But you can't even open it, so he must have just, the dates must have
Yeah.
some stuff.
That's
I was like, okay, I'm not worried about that.
fine.
But yeah, okay, so Thursday I won't be here.
Okay.
I will be in Provo.
Okay.
But I can still meet up, like I can still
Yeah.
get on for the meeting.
Okay, cool.
I just won't be
Yeah.
here. So we have a quiz that day too.
Yeah. Well, we'll get it worked out.
Well, it's only, I looked at the quiz, it's only like 4 problems or so. So what I can do is like, example, I'm trying to get all my biology homework done before I have to go.
Uh-huh.